Hey, and welcome. So this is kind of an odd or different video. Don't have a script for this, and this isn't related to a specific course or anything. This is a review, basically, of basic math concepts or principles that I personally, but I've also got feedback from other instructors and stuff, have found that students over the years sometimes struggle with or don't understand. Um, And it's sometimes stuff that it's not really something students even know to ask about to get help in understanding. Um, there are things that are covered in, grade school level maths, and that's not a shot against you if it's stuff that you maybe you don't understand before. Um, but so yeah, if you feel, comfortable and confident in your math skills, this video probably won't be of too much help to you. But if you're someone who maybe has struggled to understand some of the math concepts in nursing, or you're worried about how we use math in nursing, this might be useful to you. And so again, me saying that they're basic math concepts or principles doesn't mean that you should feel bad or stupid or, unqualified or something because you don't understand them. It's more just that they're kind of like basic principles and that they're foundational. And that sometimes even when you're in math courses, um, your teachers don't even think to like go over this stuff at any point. And so some of it might seem obvious and some of it might seem basic, but it's just never actually been spelled out to you. And so that's sometimes why people struggle with this stuff. So I'm just doing this kind of on the fly. And again, I'm just kind of going over a smattering of things. But hopefully it'll help some of y'all that maybe are finding you struggle with math and are worried about your math skills, especially as it relates to nursing. So the first thing I guess I'd start with though is to say that the math in nursing is relatively easy. And again, I'm not saying that to make you feel bad if you don't understand it. I just mean that it's not very high level math. The math that we do in nursing is really just algebra. And I know that that doesn't mean that algebra is always easy, but it's not, something really complex like trigonometry or calculus or some of those really, really high level maths that some of y'all might have taken in high school or maybe even in college if you had another um, degree or career before you decided to go into nursing. So, yeah, with that out of the way, we're not going to get any more complicated than algebra in any of our courses. If you have understanding of algebra and some of those other level maths, it can be useful, but it's definitely not required. So, and again, I'm talking extremely basic. So I apologize if this again seems way too basic, but also again, I'm not trying to make anybody feel stupid. So when we are talking about numbers, this is a whole number, right? So a whole number means that it is a whole one, right? When we use the number one, that means there is one of something, one pie. We have a whole pie, right? If you say two, that means you have two pies. And I might use pie a lot as an example because you can, when you do fractions, it makes more sense when you look at a pie, right? That's why a lot of math textbooks use it. But when we say a whole number, we're talking about this. Now, the reason I'm bringing up, like, why do we have to talk about what a whole number is, like, that might seem really basic. When we talk about rounding, right? Rounding is really important in nursing math. And the rules that we use and when we round and how we round, they're often dictated by the medication we're using or the delivery method that we're using for that medication. So just as an example, if we're giving pills, usually, though not often, usually we're like rounding to the nearest whole number. Now, usually you don't have to round. Usually it's, you give them one pill or two pills of a substance. Sometimes you do, though, have to give half of a pill, or maybe even a third or a quarter of a pill, or one and a half pills, or something like that. But usually, you're talking about one pill. Same thing when we talk about milliliters, right? So milliliters is a measurement of volume. Usually we're rounding to the nearest whole milliliter, right? But sometimes we do actually round to fractions of a milliliter, right? So again, one is a whole number, 12 is a whole number, 76. These are whole numbers, right? But when we say round to the nearest whole number, that means we're rounding to the ones place, right? So another thing to maybe talk about. So when I talk about whole numbers, there's also fractions of a number, which are not whole numbers. And that would be something like this, 0.1 or zero point 0.5, right? Or another way to think about it, if it helps, is as a fraction. So like 3/4. Oops, this way. I mean, that's also a fraction, but it's no. So 3/4, right? 3/4, and let me make this a little bit bigger too. It might make it easier for everybody to see. I don't know how it's going to show up on the recording, but it will let me. There we go. Um, so this is also a fraction, right? This is not a whole number. So again, when we say round to the nearest whole number, that would mean if you have a number like 0.5, you would round this up to 1, right? Because it's closest to 1. The general rule for rounding is if you are zero point 0.5 or above, you round up. If you're zero point 0.4 or below, you round down, right? And so 0.5, you would round up to 1. If it was 0.4, that would be 0, basically. Now, that might sound stupid. You say, like, well, why would we round to 0? Because if something is more than nothing, right? Usually we're not rounding to 1 or 0. Usually we have a number like 13.4, right? And so we say round to the nearest whole number. Well, this would make it 13, right? But if it was maybe 13.7 is the answer you got, we would round this to 14, right? Hopefully that makes sense to everybody. So again, leading kind of going back a step, but then it's going to lead back into what we were just talking about with rounding and everything. When we talk about whole numbers, this is the ones place, right? This is the tens place. This is the hundreds place. This is the thousands place. This is the, and here I'll even put 10,000s place. Usually we don't use commas, but I'm just going to do it just to hopefully make it a little bit easier to. This is the 100,000s place. This is the 1 millions place, and on into infinity, right? So where the one is, that's the placeholder, right, for the number. So this is one, this is 10, this is 100, 1,000, 10,000, 100,000, 1 million, right? So this one is in the ones place, this 10 is in the tens place, the hundreds place, the thousands place, right? The number, it's how many spaces we've gone right to the left. So again, if we say round to the nearest whole number, usually we're talking about rounding to the nearest whole number. That's usually what we're doing. Sometimes though, it might be round to the nearest hundreds or tens of a unit, right? And so we would round. So that would mean if we had the number, just as an example, right? I'm going to leave this here, but if I had, which almost is never the case, but let's say we had something that asked us to round to the nearest tens of a number, TENS, because 10, 10, tens place. If we had a number like 17, we would round that to the number 20, right? Because we're rounding to this space. So any numbers that come after it, we're taking this value and rounding it up or down to change this value, right? That's how rounding works. And again, some of this is probably basic. Similarly, if this number was 14, we would round down to 10, right? Just like before. Now, putting this down because, and I might have to dangle this a little bit, but if we go the opposite way, 0.1, right? This is the tenths place, right? So here, I'm just gonna tens, tenths, right? Hundreds. Here, if we do the same thing, now this is the hundredths. I might be spelling it incorrectly. I'm not sure. Oh, okay. No, we're good. And so on and so on. I'm not going to do that for every single one. But this would be the thousandths place. This would be the tens of thousands, on and on. Um, Now this is important because when we round again, usually we are rounding in nursing to a whole unit, or possibly if we have a fraction of a unit, we're going to be rounding to the tenths or the hundredths, right? So this is kind of where we live usually. Sometimes we might round to here, but usually this is kind of like where we're living. Usually it's in here, right? I want to make sure that's understood that when we say the nearest whole unit, that's this. This is one whole unit, right? This is a tenth of a unit. This is a hundredth of a unit. This is, thousand. It's on and on and on. So when we say this something, and I'm going to kind of switch between Word and Paint, just depending on what kind of makes more sense. When we talk about a whole, we're saying, and my drawing is terrible, especially in Paint, but this is a whole. That's a one, right? If we want to say um, the tenths right? We wanted to say, well, what if we have only 0.1 of something? That's like saying we take this circle, and I'm going to do a terrible job of it, but we cut it into 10 different sections, right? I'm not going to be able to do it. So that should be, hey, we have to do another one. And yeah, like I said, I don't know where we would even put it, but we'll just say this. So it's not going to be equal sections, but now we've got 10 sections, right? It's like this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 0.10. Each one of those segments represents 0.1, right? And let me, sorry, just erase all this. If we said, we have 10, so this the opposite way. So that was the tenths. 10 would be we've got one, but then we've got two, three, four, five, six, seven, eight, nine, 10, right? So simple. And again, each one of these we could then break down into tenths or hundredths or something like that, right? So if we had a situation where somebody was, we had to give somebody 2.5 pills, that would look like one pill, two pills, and then if we have a pill, we would say, all right, here's a pill. Oops. But now we're going to cut it in half, right? And so all we would end up giving is one half of a pill, right? And that would be like saying 2.5. The same is true for volumes. So again, in nursing, we use a lot of volumes. So if we talk about milliliters, it's a little bit harder to draw, but you could imagine it like we have a beaker or something, right? And so each, milliliter, and again, you gotta forgive my horrible drawing, but let's say from the bottom to here is 1 ml, right? And so this would then be two, three, four, five, six, seven, eight, and I should probably do another one, but we'll just leave it there. Up here we'll just say that's eight. Again, sorry if my drawing in paint is really bad. If we were giving 1.5 mils, that would mean we're gonna give this much, and I could say like, okay, all this. But then from one to two, there's going to be little fractions of a one, right? Like each one of these is basically like a whole unit unto itself, right? So if we're giving 1.5, we'd have to say, okay, well, what's half of that? Well, again, you'd have to imagine this is in reality, it's graduated and it's easier to see and not just eyeballing it, but it'd be like this would be 1.1, 1.2, 1.3, 1.4, 1.5 or something. And so here's our half, right? And so then this is how much we're giving, right? Hopefully that makes a bit of sense. And so that's the basics of how we use rounding, right? Um, Sometimes what students get confused with is this idea that they kind of mix up like tens or tenths. They don't understand the decimal place and the wording that we use for each one of these, right? And then what's compounding that is that we use a lot of different measurements in nursing. So for example, I'm going to get rid of this. That makes sense to everybody. We use things like milliliters, right? And that's how we abbreviate it. We also use things like, milligrams. We use kilograms, right? We use even something called units. Some things are measured in units, which can be kind of confusing because it's just like how many units of this, and it's not even um, it's just the specific way we measure that specific medication or dosage or something. So there's all kinds of different measurements we use. And when we're rounding, again, what we're rounding to kind of depends on each unit and like what or again not necessarily units, but each type of unit, right? So mils or kilograms or milligrams or something else that we're using that we're trying to find. It's standard kind of to round to a certain value for each of those measurements, depending on what you're giving and how you're giving it, etc. Um, so another thing that sometimes confuses students is when we're rounding and using um, fractions and numbers, right? People sometimes get confused because I think they have a fundamental misunderstanding of what decimals are and what fractions are. And this especially comes true when we talk about timings of medications and how we time out things and the length of time of things. So again, all this stuff is like reviews of basic principles. So if you understand it, don't be surprised. But if you don't, this isn't talking down to you or anything. Something that sometimes people don't understand is numbers like 0.1, right? That's the same as 1/10, right? The fraction 1/10, which is also the same as saying 1%. This is all the same way to represent the same value of something, right? And if that doesn't make sense, it's maybe I can try to help you, is if you take 0.1 and you say, how do I get from 0.1 to 10? You'd say, well, plus 0.1. Whoops, it's the wrong. Plus 0.1 plus 0.1 plus. Stop counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you add all those together, that's 1, right? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 10, which again we round over, so now it's 1, right? And so there's 10 0.1s to get to 1. So that's the same as saying 1/10, because 1/10 is like saying, let's take that circle again and we cut it into our, again, I can't do it very well, but 10 slices, right? Or I don't know where the best place to draw again, this would be, you got 10 slices, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So effectively 1/10 is representing this. 0.1 is kind of almost more representing like a beaker or something, right? So again, if we just say this is 1 mil at the top here, that would make this is like 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then 1. And again, don't ignore that they're not balanced. I just am drawing badly. So 1/10 is like saying this. We just want that little slice. 0.1 is like saying we want this, right? And actually, I just realized, sorry, I made a mistake here. So sorry if I confused anybody. That's 10%. Sorry, I just realized talking about this. It's 10%. So see, even we can all make math mistakes sometimes. So yeah. And the reason this is 10% is when we talk about percentages, we're talking about out of a whole, right? 100% means all of something. So again, going back to here, all of this, that's 100%. All of this, that's 100%, right? If we say 10%, well, that's saying cut it into 10 pieces, however. So 10 pieces this way, 10 pieces that way, right? Now, some people might say, yeah, I know how to round, I know all this stuff, and you're stupid because you thought, 0.1 was 1% for a second there. Just I'm doing this on script. But the reason I'm going over this is sometimes people get a little confused as to the interaction, like how this kind of works in practice. So like I'll give you an example that is very common for students to make a mistake about. How many times have you put in a number in a calculator or something, you get 0.3333333? Or, and I don't know the alt function on Word, I apologize, but 0.3, and it'll have like a line over the 3. So I don't know how to do that in Word, sorry. I know how to put a line under it, but not over it. When you see a line over something, that means it repeats forever. So the number when you see 0.33333 in a calculator, then what sometimes students will do is they'll plug in 0.33333 and multiply it, or divide by it, or do whatever they need to do in their equation. And it gives them sometimes issues with rounding because see, this number isn't actually 0.3333333, up to this point. It's actually the number 1/3. And a calculator can't represent a third of something because it's like infinitesimal. Okay. Because we use, and I don't mean to get too complicated, but because we use a base 10 counting system as humans, that because we have 10 fingers. So we say, 0 through 9 is just taking up, the ones place. And then once we get to 10, we add a 0. Well, it's because we have 10 fingers basically. And so we count, like this, and then we say, okay, I counted to 10, my fingers are full. So now let me put a mark somewhere else. Well, this 10's place, this is putting a mark someplace else so we can free up our fingers to count to 10 again, right? And then we turn it into 20 and so on. if we had, and I'm not trying to confuse you with this, I apologize if it does, and you don't have to, you can ignore this part if it's confusing. If we had seven fingers, for example, we'd count 0 to 7, and then we'd say one, and then we'd say, you know, or then we'd say 10, and then we'd say 11, 12, 13, 14, 15, 16, 17, and then we'd say 18, if that makes sense. So basically you'd say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's an example, right? So obviously we don't use base 7. If anybody's familiar with something called like binary code, like encoding, binary code is zeros and ones, right? Because it's either yes or no. And so when you're coding and stuff, it's like 0, 1. Now it becomes 1, 0, 1, 1. Now it'd be 1, 1 or 1, 0, 0. And then 1, 0 or 1, 0, 1. 1, 1, 0. Oops, sorry, it's hard to do with the talk at the same time. 1, 1, 0, on and on and on. You see how this goes. That's and I apologize if I confuse anybody, but basically what I'm getting at is you can't represent a number like 1/3 in a decimal place or in a fraction accurately because we use a base 10 counting system, and 10 divided by 3, it doesn't work. You can't divide 3 into 10 evenly, right? When you divide 10 by 3, you get 0 point like 3, right? So this whole long, maybe confusing aside is because sometimes when students see this number, they don't think about it in practical terms. They think about the math in terms of like, oh, just the numbers. But remember, we're talking about physical items in nursing. It's not theoretical. We're practical when we talk about math. So the most often time this comes up is when we'll say, we're trying to figure out, all right, how long is a medication going to infuse over? How much time is it going to take? And so, like, let me give an example. Actually, it might make it easier. I don't know, but I have to come up with the math in my head. But let's say we have a doesn't matter what the medication is. It's 100 mils, right? And um, it's going to diffuse at a rate of 300 mils per hour, right? How long will it take this medication to infuse over, right? This is a pretty easy math question, but it would be one that you might have. So if you do this math, and the process we use is something called dimensional analysis, which I can get into a little bit at the end, so ignore that for now. But if we're trying to figure out how many hours something's going to take, it's like, okay, we have 100 milliliters, and it's going to infuse over 300 mils. So what we would do is we'd say 100 milliliters, right? And then we would say divided by 300 mils per hour, right? And when you do that, I'm just pulling this up so you believe me. But if we do 100 divided by 300, right, you get that number, 0.333. This doesn't really make sense. We don't talk like this, right? And the way to think about this too, and again, I apologize for jumping around a lot. I'll come back to this concept, but 100 mils. Me writing this up here is the same as writing this. It's 100 mils divided by 300 mils per hour. So whenever you are doing division, right, and fractions, you want to simplify them. So for example, in this numerator, that's the top number, these two zeros, those cancel out these two zeros, right? If something's on the top and something's on the bottom, it cancels it out. And if you don't understand that, that's because 1, right, divided by 1 equals 1. You don't want that underlined. When you have a fraction, it's the same as saying this top number divided by that bottom number. A fraction is just the same way of saying that. If you have, 1 over 5, that's the same as saying, and I'm just using the slash to be over for right now, that's the same as saying 1 divided by 5, which is 0.2, right? Or, or 1/5, or, however you want to represent it. So, in this case, again, 1 over 1 equals 1 because it cancels it out. It's the same. 0 over 0 is 0. 0 over 0 is 0. Mills over mills is like all this is one. So we just can say none of this even exists, right? Because it's all the same. And that leaves us with 1/3 of an hour, which is 0.3333 hours. Now, again, going back to the idea behind this question, and sometimes the thing people make mistakes with, we don't talk like this in life. We don't say it's going to finish in 0.33333 hours, right? We might say 1/3 of an hour, but in reality, it's going to finish in 20 minutes, right? That's what this answer actually is telling you. And if you don't understand that, that's because if we imagine a clock, right? We have a clock face, right? And this is minute 60 at the top, right? And it goes around. So you've got like, 1, 2, 3, 4, 5 minutes. 1, 2, 3, 4, 5 minutes, 1, 2, 3, 4, 5 minutes. We all hopefully know how a clock works. And you imagine the minute hands on the clock, right? A third of this would be saying, let's take this clock, and again, you got to cut me some slack on the drawing, cut it into thirds. Well, a third, if you divide it into three evenly portioned pieces, the clock, that's 20 minutes, right? Because 1, 2, 3, 4, 5, and here's another 20. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That would be, the halfway point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's you get on and on and on. I'm not gonna bore y'all by drawing all of a clock. Um, but yeah, so we don't say 1/3 of an hour. I mean, you might say 1/3 of an hour, but we don't say 0.3333333 hours. We say it's 1/3 of an hour or 20 minutes, right? So that's something that sometimes can confuse people is understanding how especially when we talked about times like fractions of hours or even fractions of minutes sometimes because you usually don't need to worry about that, but that might come up. Um so yeah, so that's one thing that sometimes can confuse people a little bit is this concept of like understanding, or the same thing. If this was asking us how many pills would you give, and it was 0.33333 pills, well, we don't give 0.333. We cut it into thirds of a pieces, which I've never seen a pill needing to be cut into a third of a piece. It'd be kind of hard to do. But we oftentimes cut things in half or something. Um, and that's what we're doing when we talk about a half of a pill, right? And I just went over this a second ago, but I'm going to go into a little bit more depth. But yeah, whenever you see 1/2, right, 1/2, that's the same as saying 1 divided by 2. And that's why I can say 1 divided by 2 equals 0.5. Because if you don't believe me, 1 divided by 2 equals 0.5, right? And again, this is the same as saying 50%, right? Because it's half of one of a whole. If you had two halves, you'd get one, which would be 100%. Um, the reason I bring this up is oftentimes you'll see, I don't know, some of y'all probably see like memes and things that are like how to do this math problem. And it's like, um, I don't know where the division sign is in Word. Let's find it out together. Alt 246. Okay, let's make sure that's actually the case. All right, there we go. Perfect. Sorry. Let's say we have you might have seen like something that's like 2 times, 4 plus 6, and then like divided by, 2 parentheses 6 times 4, right? And they'll be like, what's the answer? And people give all kinds of different answers because they're like, oh, well, this is the order of operations. That's the order of operations. The reality is like you want your math to be clear, and using something like this isn't very clear, right? And that's why you see the memes that are like, oh, the answer is this number, but then it's this number. And you have people doing the same math equation, they're getting different answers because they're doing their order of operations wrong, but also because sometimes the order of operations is presented not clearly. So when you set up your problems, you want to set up the order of operations clearly. Part of doing that is understanding this idea of this division symbol is the same as saying basically all of this divided by all this, or at least it should be. Again, that's where the frustration sometimes comes in with doing these, and it's because it's like, oh, that's not actually the order of operations. To make it clearer, and again, if this is what you actually intended, What you should really be doing is saying all this is over, right? So all that's going to be divided by all this. So this, you're going to do this, figure this number out. Then you're going to figure this number out. Then, you'll divide this, your numerator, by your denominator, right? So that's sometimes an important thing to remember is you want to set up your math problems such that they're clear to you because you're the one doing it. So another thing is in the nursing program, we use and we teach y'all a process called dimensional analysis. And it's what I showed a second ago, where we had, mils over hours, and I turned that into hours. When we talk about nursing math, again, we're doing algebra. And so oftentimes you need to take different measurements and convert them into another measurement. So just as an example, let's try to think of another example real quick. These are easy, basic examples. They're going to get more complicated as you go on. But let's say we need to give we need to, whoops, we need to, it's the problem of doing this live, right? We need to give 10 milligrams of some drug to a person per kilogram they weigh, right? Person weighs 5 kilograms. How much drug do we give, right? In this example, what we're trying to do is we're trying to figure out, well, how much of this drug do we give? So when we use dimensional analysis, and again, you'll have math classes that go into dimensional analysis, but I'm going to go into it a little bit now, hopefully to help it make a little more sense to everybody. What we want to do is we want to first always ask ourselves, what am I trying to find? Okay. What I'm trying to find in this question is how much of the drug are we going to give a person? How do we measure the drug? I look in my problem, it says we need to give 10 milligrams of drug to a person per kilogram they weigh. So regardless of anything else, the way I'm going to measure my drug is in milligrams, right? Right now, I don't know how much. So X, in algebra and stuff, we always say like X this or Y that. That's why, because we're saying we don't know. It's like a question mark. So X milligrams, that's what I'm trying to find. Or if it helps, question mark milligrams. Well, whatever that number is, it's going to be equal to this stuff, right? To something. So the way we want to go about this is, all right, I need to figure out how many milligrams of something to give. In dimensional analysis, we kind of use a process where, like I showed you before, if we have one and it's over one, the ones cancel each other out and they become one. Or if you have a three over a three, that's one. If you have variables, that's what sometimes we use in algebra is variables. X over X, that's going to equal one no matter what this number is, it's going to equal one because something divided by itself is one, right? No matter what. So we use that principle to say, well, okay, then when it comes to units of measurement, if we change that X to, let's just say milligram, if we have, 1 milligram over 1 milligram, that also, these milligrams cancel out and we're just left with, like 1 milligram. But, it's 1 milligram divided by 1 milligram is just one, you know? So to that end, we're going to say, well, then let's start with what we have, what we know we have. We have milligrams. So what do we know? We know we have to give 10 milligrams. So our concentration, basically, this is what we call our concentration. We're going to give 10 milligrams. Well, 10 milligrams of drug per kilogram. Does that make sense? So that means what we're going to do is we're going to say, okay, so for every kilogram the person weighs, oops, we're going to give 10 milligrams. So you could make this 1 kilogram, whatever, but for every kilogram, 10 milligrams, right? Because 10 divided by 1 is 10, etc. Now that might seem a little confusing because you say, well, what if they weigh 5 kilograms, so shouldn't we put a 5 here? No, we shouldn't, because if we did that, this would simplify to 10 divided by 5, which is 2. We would give a person 2 milligrams? It doesn't make any sense. No, it's 10 milligrams per kilo. So we're just saying for every kilogram, we're going to give 10 milligrams. Now's where the dimensional analysis part comes in. So then now we have to say, well, wait a second. I want to simplify this. I don't want kilograms down here. I just want milligrams. That's how many I'm trying to figure out. Now is when we say, well, the way we get rid of this kilogram is we got to imagine that our numerator goes on forever, as does our denominator, right? So anything I put up here is part of the numerator, the same numerator. So I want to get rid of this kilograms. I just want it in milligrams. How do I do that? Well, they're 5 kilograms. And it says 10 milligrams of some drug per kilo. So that would mean 10 times 5. So if I say, well, 10 milligrams times 5 kilograms, right? That is going to, how do we strike there? There we go. Cancel out those kilograms, right? And then we just say, well, now we just got milligrams. 10 milligrams times 5 would equal 50 milligrams, right? Oops, let me move that a little bit so here. Oh, there we go. So again, I made that super long because you can keep this going forever, right? But this is our answer. Or if you helped, you put it over here now, 50 milligrams. That's our answer to this question. This can get much more complicated, and it's going to get more complicated as you go on, but that's the basics of dimensional analysis. It's a way to convert from one unit of measurement into another, like using multiple different units of measurement stuff. So let me make this, I'm going to make this a little bit more challenging. Again, it's not, if this is something you're struggling with, again, you're going to get more videos on this. And depending on when you're watching this, you might have already seen videos about this. Again, I'm doing this for, Santa Fe, so I assume all y'all are doing the normal course progression and video progression in Santa Fe. But depending on when you're watching this, you might not have seen it or something. These might be new concepts. I don't know, maybe if you've stumbled upon this before you even got into the program or something, before the first day of class, you've gotten access to some of the course material and you're reviewing it or something. Um, let's change this. This person doesn't weigh 5 kilograms. They weigh 5 pounds. That's the symbol for pounds, right? Well, so obviously, first off, we'd be talking about a baby, not a. We still give medicine to babies, right, if they need it. But yeah, we're talking about 5 pounds now. This becomes a bit more complicated, and I'm not going to spend a ton of time going through this. Just because, again, you're going to have whole courses on this. But to give you an example of why we use this system and how it can be used. So we're still trying to find X milligrams, right? And the start is still the same. We have 10 milligrams. 10 milligrams per what we said? Well, oh, sorry. I don't really like using word for math, but I don't really know any other good options and stuff. So I kind of just keep using it per 1 kilogram, right? Or per kilogram. So again, you could think of this as one, or you could think of it as just a kilogram, but whatever. But we have a problem. So before, when we did this, we knew the person weighed 5 kilograms. And so we said, well, it says 10 milligrams per kilogram. So we just 10 times 5, and that's the answer. And you're like, why did you spend all this time wasting my time teaching me how to do this? This is basic fourth grade math. I learned this, whatever. But this is why, because it can get a little more complicated. Well, we don't know their weight in kilograms. We know their weight in pounds. So what do we have to do? Well, now we have to use a conversion factor. And this is how it can start getting more complicated and how we have to start doing things. So person weighs 5 pounds, but we don't want it in pounds. We want kilograms. So if you don't know it, and I mean, I do know it, it's like 2.2, but how many pounds in a kilogram? All right, there's 2.2. And so for our purposes, usually, again, it depends on our rounding rule. Usually we say 2.2. I just Googled it so you'd believe me, but you'd say 2.2. It's not exactly accurate, but it's accurate to a degree that is acceptable, right? Whenever you're dealing with real world math and real world dose calculations, there's the expectation that there's going to be a little bit of a difference, right? When you hang an IV medication, for example, you have to prime your IV line. And so you lose sometimes a little bit of the medication. And so we accept that like it's within, an acceptable amount of loss or extra or something. It doesn't have to be super precise. If it does have to be super precise, the rounding rules and such will indicate that. And so for this case, we'll just say we're rounding to the nearest you know, whole kilogram. It doesn't, I'll show you. Then we'll just see what our answer is and we'll go from there. But the point is, we're going to say, okay, well, we just said 1 kilogram is 2.2 pounds, right? Huh. Well, so now what that means is to get rid of this kilogram, we need to put kilograms up here. And what did we just learn? We learned 1 kilogram is the same as 2.2 pounds, right? That's significant because guess what? You say, well, all right, we did it. We got rid of the kilogram, but Ransom, you horrible monster. This is even worse. Now we've got pounds down here, right? How do we get rid of that? I'm glad you asked. Although I don't appreciate you calling me a horrible monster. Patient weighs 5 pounds. And we don't need to put anything down here. If it helps, if you know, it helps you to think that you could put one patient, right? Because we're asking how much drug do we give to the patient, this many milligrams per patient, whatever. But essentially, now we're left with just milligrams, right? Because this pounds, was it Control X, I think? Oh, nope. Don't want to do that. Sorry. What's the strike through command? Control Shift X. Apologies. Too many buttons. 2 buttons is my limit, not 3. So those 2 pounds cancel out, right? And these 2 kilos cancel out because they're on the numerator and the denominator. So now this is the equation really, right? So to make it a little bit simpler, I don't know if it's actually simpler, but the way to think about this is 10 times 5, right? Divided by 2.2. And that's going to give us our answer, right? So we'd say 10 times 5 equals divided by 2.2. Is 22.7. So sorry, I'm trying to figure out 22.727, 27, whatever milligrams is how much the person or the baby, I guess, would get. Now, I told you I didn't set a a rounding rule for this. So we'd have to say, okay, the person weighs about 2 kilos. So if we were rounding to the nearest whole number, right? So again, if we're rounding to the nearest whole number, 22.7, we would say is 23 milligrams. Does that make sense? Usually always, I should say, not usually, always when we round, whatever unit we're rounding to, so like if we're rounding to the nearest whole milligram, that means we use this number to round, if that makes sense. The reason I bring that up is if you had a number like 1.454545, and I said, round to the nearest whole number, so here, you say, well, this is less than 5, so I round down. But wait, this is less, or this is more than 5. So I should round that up here. So that becomes a 5. And now this is higher, and that's not how it works, right? We don't do that. We don't go back, and because you could have a number that's like this, and you say, okay, well, sorry, I got started getting a little too aggressive typing fours there. But you go on forever and ever, and you're like, well, okay, but this number changes that number. No, this is 1.4, right? 1.45. It's less than 0.1, it's less than 1.5, so we round down, not up, right? So again, not to confuse you, sorry, but this is 22.7, so it's not, in any way confusing. We say that the answer is now 23 milligrams. If I asked you to round to the nearest 10th of a milligram, right? So if this would be OMGs, if I said that, it'd be 22.7 tenths of a milligram, right? Now, just for the sake of argument, though, just to again show you how this works, if I asked you to round to the nearest hundredth of a milligram, which I can't imagine anybody ever would, but let's just say that would mean we say, okay, here's our whole numbers, tenths, hundredths. That means we're now looking over here. So now our answer would be 22.73 milligrams if we were rounding to the hundredths of a milligram. Because again, whatever place I tell you to round to. So again, round to the nearest whole number. It's 22. We look at 0.7. We round it up to 23. Okay. Nearest tenth of a mil, 22.7. The number behind the tenths place is a 2, so we round down, so it stays the same. Round to the nearest hundredths of a milligram, 22.73. So here's our hundredths place right here. That's a 7, so that would go up to a 0.3. or 0.73, I should say. I make it hundreds of a milligram. So apologies if that's a lot, or maybe not enough. I don't know. Um, but that's how we round. Again, it's always going to depend on what the instructions are, what the rounding rules are, what the rounding instructions are. And this is also, again, how we use dimensional analysis. So if it was a little confusing, like I said, you'll have whole courses dedicated to it. This is more of a kind of potpourri, if you will, like a catch-all kind of just review or discussion around math principles. One last thing I'll say about this dimensional analysis, right? What I just showed you. In math, a lot of times people approach it with a mindset of, I need to memorize the formula of how I solve this problem. And I think that's because that's how a lot of us were taught math when we were younger. It was like, I mean, I don't know about y'all, but when I was in high school algebra, we had a whole year basically of just memorizing and using the quadratic equation. Um, and now I can't, if you put me on the spot, I don't think I even remember the quadratic equation. But luckily, I'm not on the spot. I don't have to answer to any of y'all about what the quadratic equation works. I've never had to use it in practice. But it's how you find like parabolas and the how to chart them and stuff. But the point is, yeah, you just spend all this time memorizing how the quadratic equation works and how you use it and how you apply it and stuff. Dimensional analysis isn't like that. The math we're doing isn't formulas that you memorize. It's a process. It's more about you need to understand the principle and the concept. Because what I just showed you, this same process can work the same if we're saying 10 milliliters of a drug to the person per kilogram they weigh, right? Or you're going to give them 2 milligrams. Another way, and I'm not going to solve this one for you, and I don't want to confuse you, but we might say we need to give 10 milligrams of some drug per person per kilogram they weigh. The drug is available in a concentration of 10 milligrams, I was going to per 5 milliliters. Person weighs 5 pounds. How many milliliters will we draw up, right? In this case, again, this would add a whole nother wrinkle into so here we'd have to change this because we're not trying to find milligrams anymore. We'd be trying to find mils, and we have to add another step in our dimensional analysis. So again, I'm not, hopefully this doesn't confuse anybody, but it's more saying it's the principles, it's the concept that's important to understand. It's important to understand what we're doing. So in the example before, right, I'm going to maybe draw a little representation. We're saying we're going to give 10 milligrams to a person. So again, you got to, sorry, here's our person, right? I'm just going to draw stick figures because it's easier. And they're happy. Why not? Because they're listening to me talk. So here's our person, right? We're going to give them 10 milligrams for every kilo they are. If we say again that they're 5 kilos, that means, and oh, I'm so sorry, little person I just drew, but we got to cut them into like 5 equal parts, right? Because they're, one is this. Well, there's 5 kilograms, so that means, oh, sorry, one kilo's up here, 2 kilos. So we'll just do this here is 3 kilos, and then 4 and 5. Again, imagine that these are all equally balanced. That would mean each one of these kilos needs 10 milligrams, and on and on and on. And when you do all that, 10 plus 20 plus 30 plus 40 plus 50 is 50 milligrams, right? That's how that works. That's the basics of of what we're doing, right? That's the math we were doing. Um, Similarly, when we talk about concentrations, oftentimes we have a vial of liquid, right? So again, we have like a beaker or a vial or a cup or something like that. And there's 2 milliliters total, right? I'm making this up. From here to here, or actually, I guess we'll say the whole thing is 2 milliliters, right? So it's 2 mils. But we'll say that in this 2 mils is 50 milligrams of some drug, right? Of drug. Sorry, it's hard to draw. And I can't really do this in paint very easily. Of drug, 50 milligrams of drug, right? So what you have to imagine, this is whenever you have a vial of a drug that you have to draw up a lot of times, It's about how much of that active ingredient is in the mixture, right? It's kind of like imagine a cup and you pour some salt into the cup. However much salt you pour in, that's how much, you know, the concentration is. So in this example, we're saying, well, we want to give the drug. The drug is salt that we've poured into a mixture to keep it nice and stable, right? So it'll sit in that little puddle of water. So there's a little bit of water in there mixed with that the drug is mixed in. So if we want to give however much of the drug or the salt, we got to know, well, what's the concentration, right? So in this case, it's telling us this is 2 milliliters and there's 50 milligrams of the drug in it. That means if we cut it in half, right, this would be 1 ml, this would be 1 ml, and in this half, there's 25 milligrams, and in this half, there's 25 milligrams as well. So again, if we're wanting to give 25 milligrams of this drug, we draw up 1 milliliter out of this vial. We wouldn't draw up both. We'd just draw up one or some other number, right? Like it go on and on. It might be we only gonna give again 10 milligrams of the drug, whatever. So in our example before, again, I keep saying the patient was 5 kilos. We're giving them 50 milligrams. In this case, we would need to draw up 2 milliliters because that's the concentration, and that's what we would end up giving them. Hopefully that makes sense. Again, some of this might be a little bit beyond where y'all are at, depending on when you're watching this. Some of this might be behind where you're at. I don't know, but it's hopefully meant to serve as a way to review just the basics of math, how some of this stuff works. I know oftentimes in school, and I'll kind of start wrapping up on this point, especially in nursing school, there's a lot of terminology we use and a lot of specific, medical terms, terms that we use in healthcare. One of the things I always try to do is I always try to define the term every time I use it when I'm teaching, because I know that in class there's always one, and I usually ask, I say, does everybody know what that means? And everybody's silent. They just kind of nod their head. But I always know there's one person who doesn't know what it means, and they're too afraid to ask. Because at one point a year ago, somebody said what the word was, and they weren't paying attention, or they looked down at their phone, or they missed class or whatever, and they didn't hear it, and they keep hearing now that term, and they're like, what does that mean again? Then maybe they've asked a time or two, like, what does that mean again? And somebody told them, like, okay, but then they forgot. And so now they're like, I know we were supposed to learn that a year ago, and I still haven't. So, like, I'm going to just shut up and hopefully nobody catches on that I don't know it. And that's not how you want to be. First off, I just assume that you're going to do that. Um, and I don't mean that as a shot against anybody. I mean that as a nurse, a good rule of thumb is you always want to assume the worst about everyone. Not in that they're bad people, but that like whatever could go wrong will go wrong, and that helps you be better prepared and be more proactive. Um, but yeah, what I'm getting at is basically that I know that sometimes people don't understand that stuff. And so similarly with like I think a lot of math, students sometimes learn a concept and they maybe even think they know it, and then as they go on, they realize like, oh, I still don't quite understand that. But they're afraid to ask for help about a concept because they feel like it's behind them and that we've already passed that. And if they don't know it, it's going to reflect poorly on them. Piece of advice I would give you in nursing school, and again, some of y'all might be about to graduate, some of y'all might not even, you know, you might have just gotten into nursing school, you might be in the middle of the program, I don't know. Yeah, this video will probably be uploaded onto YouTube, so there might even be some of y'all who aren't even in nursing school, and I don't know if this is just your Friday night and you're sitting in your pajamas, eating junk food and watching this for God only knows what reason. But YouTube might have pointed you this way. The point is, when you're in nursing school, if you are in nursing school, but when you're in nursing school, um, you don't want to be that way. You don't have that attitude. You want to have an attitude of if I don't understand something, I want to ask about it. I want to get clarification. So what I would encourage all of y'all, if there's something you don't understand and you think like I shouldn't ask about that because it's like a basic concept I should have learned on like the second day, but I still haven't gotten it, ask. We do not want you to be afraid of being an idiot or feeling like, oh, they're going to think I'm stupid or I'm not a good student. We don't want you to be afraid of that, because we are stupid. We are idiots. If all of your instructors are stupid and idiots, you are, yeah, we don't think that you're stupid as an idiot. We know that because we all are. Every single one of us is. The reason we go over this math is because nurses make math mistakes, all of us. I, as a nurse, have made plenty of med errors. I've caught a lot of them, thankfully, but there's been some I haven't. And any of my colleagues will tell you the same thing. Every nurse who's worth their salt will tell you, yeah, I've made med errors. If you ever meet a nurse that tells you, I've never made a med error, that's actually a really troubling thing because that person means that person has never caught any of their own med errors, which is even worse. That what you want to be is somebody who's like, oh yeah, I've caught many med errors I've made. That means you're a good nurse because that means you made mistakes, but then you caught them. Somebody who says, I've never made a mistake, that's a worrying nurse because that means they've made mistakes because I promise you they have, but they never caught them and maybe nobody else ever caught them. And so that's really bad. So I'm saying this not to, I'm being a little joking. You're not actually stupid or idiots. And I like to think that I'm not stupid or an idiot, although my girlfriend and my son probably would disagree with that and say like, no, no, you're right the first time. But be humble and be understanding that like we're here to learn, we're here to understand things. There's no shame in needing to review a basic concept or a basic idea. That's why I'm making this video because it's not the expectation isn't that you should be able to do this perfectly. We're all human, we all make mistakes. There's a lot of information you have to learn, and it can be difficult to synthesize it all. So again, just wrapping up saying anytime we go over a material that you don't understand, ask for help from any of us. And really last point, I would also say we have at Santa Fe, the nursing program that we're in, we have open lab. That's time that you can go into the lab and you can practice any skills that you want within reason. Obviously, there's some that we might not have an ability to practice just because they take too much setup or something like that. But the most useful skills, the ones that you're going to be using the most in clinical, those are skills that you can practice pretty much any time. And so we encourage you to use Open Lab to practice those skills. We don't anticipate you to be perfect at them after doing them once in a practice setting. We expect you to need to practice it multiple times. And we also expect that if you haven't done it in a long time, you might need to bone up on that skill and then review it again. So never feel like, in the first semester, you're going to learn how to put Foley catheters in. If you're about to graduate and you haven't put in a Foley catheter yet, which might happen to a lot of y'all because it's a common skill, but it's not so common that you're guaranteed to do it, at some point during your nursing school time. Um, don't be afraid to go in and practice that because you're like, oh, I haven't done it yet. I want to practice a few more times before I graduate. So when I get working, when I'm asked to do it for the first time, I feel a little more confident. No one is going to judge you. We're not going to judge you and think, what is that transition student, who's about to graduate doing practicing that basic fundamental skill? No, we're going to say that's a good nursing student. That is a student who has self-assessed, who has recognized, I haven't done this skill, or I've done it, but I didn't I haven't done it in a year because I did it back a year ago in fundamentals, or I did it, but I'm not super confident, or I did it on a man and I'm still not confident doing it on a woman, or vice versa, or something like that, because the skill's a little different, depending on the gender or the genitalia they have. Um, we're going to say that's a positive thing. That means you were self-assessing and you were able to understand like that you needed to practice that. So the same is true for this math stuff. You're going to learn how to do math. We're going to build on it throughout the program. These basic ideas or concepts, if you don't understand them, it's okay. I mean, it's not okay that you don't, we want you to understand them, but it's okay if you haven't gotten there yet. We want to help you get there. So don't ever feel like it's too scary or you're too worried we're going to judge you or something. That's not going to happen. We're going to work with you to try to understand it because it takes time. We don't expect people to get this on the first try. And there's a lot of stuff you got to learn in nursing school. And yeah, sorry if this kind of got off into stuff away from math, but it's advice that I would give you to help you with the math, but it's also just going to help you through nursing school is don't be afraid to ask. Even if you feel like it's something you should already know, if you don't know it, ask, right? It's better to ask a question and maybe you look like kind of a fool for a few seconds while people are like, oh, she should already know that, ha ha ha, versus to never ask the question and you just never know. And then when something happens later in your career and you never learned it, you maybe feel even worse because you're like, oh my gosh, I could have maybe prevented a mistake or helped somebody with that knowledge and I never asked, right? But I can promise you, even if you're worried about looking foolish or something, nobody's gonna think that of you. And as I always say, like, if you're really worried about being a fool or looking foolish, just remember that you're being taught by, you know, me, who's probably the most foolish person that's ever lived. So, don't be afraid of that stuff. We're all human, we all make mistakes. And that's why I say that, because yeah, that's what we expect. So having said that, hopefully some of this has helped clarify maybe some math questions you've had that maybe you didn't have the words to ask. If you found this useful, yeah, give me feedback in the hallway or it's class or something. If you found that it wasn't useful or if there's something more that you wanted to know about, let me know because this is a kind of an experiment video of just like me going over some stuff that I've noticed over the years that students seem to struggle with and didn't understand. But there might be a lot of other things that people aren't understanding, but I haven't noticed it or they haven't told me about it. So, let me know. Yeah, comment on the video or let me know in the discussion boards on the class or, mention in person like, hey, you did that video. It was really bad, but I think the concept is really good. So maybe you could talk about this stuff. And maybe, when I have the ability to, I'll be able to make something that can help answer some of those questions for you. So, yeah, and as always, it doesn't have to be a video too. If there's something you don't understand, just reach out to me, email, ask in class. I'll be happy to meet with you one-on-one or in a group setting or whatever in my office or on campus, and we can go over it as well there. So I don't think it just has to be like me putting a video up or something. But yeah, with that, hopefully this has helped answer some math questions. Yeah, and like I said, if you're in nursing school at Santa Fe, good luck to you. Good luck to you, I guess, if you're not in nursing school at Santa Fe. Maybe you've graduated or something, you're watching this review, but yeah, hopefully this helps. So thanks.